Hi, this is Mr. Hood, and we're going to look at identifying decimal numbered sequences. So let's take a look at example A. One thing you might notice upon initial inspection is that the number of decimal places appears to be increasing in each new term. Sometimes that's a decent indicator that we have a geometric sequence, that we're multiplying. So how can we check? If we're multiplying to move forward, then we must be dividing by the same number to move backwards. So let's try this. Let's take the second term, 1.86, and divide it by the first term, 0.6. The quotient you would get is 3.1. So if this is a geometric sequence, then we should get the same quotient by taking any two numbers and dividing them. So let's take the fourth term in the sequence, 17.8746, and divide it by 5.766. And in fact, again, you will get a quotient of 3.1. So what does that mean? That means we have a geometric sequence, and because we were dividing by 3.1 to move backwards, we must be multiplying by 3.1 to move forward. So what's the rule? Since we're multiplying by 3.1, the rule is going to be 3.1n, and the next two terms in the sequence are going to be 51 and 41,126 100,000ths, and 171 and 774,906 millionths, of course. Let's take a look at example B. Well, let's use that test. So, if we think this is a geometric sequence, then we're going to divide the second term by the first term, write that answer down, then divide the fourth term by the third term, and compare those two quotients. I'm going to tell you that whatever the quotients we got will not be the same. So it's not a geometric sequence. So how can we test an arithmetic sequence? Well, in an arithmetic sequence, we add by the same number to move forward. So to test for an arithmetic sequence, we're going to subtract moving backwards. So let's take 7 minus 4.7, which is 2.3, and then take 11.6 minus 9.3. And in fact, we were going to get 2.3 again. So it is an arithmetic sequence. Because we're subtracting by 2.3 to move backwards, we must be adding by 2.3 to move forward. That makes the rule n plus 2.3, and that makes the next two terms 13.9 and 16.2. So why don't you go ahead and pause the video for a second here and take a look at example C and example D. All right, let's take a look at example C. First things first. Let's test to see if this thing is a geometric sequence. So if it's multiplication moving forward, it must be division going backwards. So we're going to divide 14.75 by 4.5, and then take 35.25 and divide it by 25. I don't know what those two quotients are, but I know they're not the same, so it's not a geometric sequence. So now let's test to see if it's an arithmetic sequence. So let's subtract going backwards. And in fact, what you would get is that each time you would get a difference of 10.25, meaning it's an arithmetic sequence because we're adding by 10.25 to move forward. Meaning the rule is n plus 10.25, and the next two terms in the sequence would be 45.5 and 55.75. Last one. So, first things first, actually let's test to see if it's arithmetic this time. So we're going to subtract going backwards, and in fact you're going to find that you don't get the same difference every time, so arithmetic's out. So let's test to see if it's a geometric sequence by dividing backwards, and in fact the quotient you would get each time is 4, meaning we're multiplying by 4 to move forward, meaning it's a geometric sequence. So that means the rule would be 4n, and the next two terms in the sequence would be 409 and 6/10 and 1,638 and 4/10.